Yeah. Okay. So this is on GitHub, Hedera dev /HCS skills. And if you just scroll down on that page, you'll see the written version of this as a tutorial. And what we'll do today is we'll be going through this in a live hands-on manner. So I'll be demonstrating how to do it on my computer, and you can follow along. What you're going to accomplish is that you're going to create a application that interacts with one of multiple services that are available on Hedera, and Ed has just covered it in a bit more detail in the slides, and we're just going to get hands-on with it, right? So that's Hedera Consensus Service, and for those of you who are familiar with publish and subscribe, right, that's or PubSub queue, that's essentially what Hedera Consensus Service does as well, HCS. So I'm just going to scroll down a bit. All right, so we're going to be using something called the Hedera SDK, which is a library. We'll be using JavaScript for this, and we'll do that. We'll create a topic, which is essentially a PubSub queue, and then we will publish messages to that topic, and then we'll also subscribe to it to get messages back, right? And we'll also use something else called the Hedera mirror node to retrieve historical messages from the HCS topic. Now, this is this mirror node concept is something that we haven't covered in the presentation, but you can think of it as the Hedera nodes that the ones with the graph and the nodes that you saw in the illustration. So those transactions or groups of transactions called events, they are stored in a very transient manner, like only for a few minutes, right, in the Hedera nodes themselves. But then once they have been propagated out to some other system that isn't in charge of consensus in terms of processing the transactions, so then that goes into something called a mirror node, right? And so the mirror node keeps a record of all historical transactions. And so if we want the live version, what's happening right now, then the Hedera nodes have them. And if we want the ones that were historical, then we can go to the mirror nodes. And finally, we'll also be doing some sort of client-side validation using something called JSON schema as well as hashing. Because in this case, the topics, you can publish any message you want to it, and we don't want other applications submitting messages just happens to be at the same topic. We want to be able to filter those out. So this is a very simple application, but it does demonstrate the basics. All right, so that's the overview, which I've covered, and you can check it out over here as well. So in terms of prerequisites, we're going to be shortcutting this by using a third-party service called Gitpod. So hope all of you have got a GitHub account, and you have a browser, Chrome preferred, and that will pretty much be all that is necessary to follow along. You don't need to do all of this stuff because Gitpod will provide that. All right, in the README, scroll down to the workshop section, and then under setup, you'll see some instructions for a Git repo, and then you'll see underneath it, alternative with Gitpod, you'll need to click on that little arrow and expand it, and that will give you some instructions, right? The first thing you need to do is go to gitpod.io/login, and that should present you with a page on Gitpod. But if it's your first time and you haven't logged in before, you'll need to click on login with GitHub, right? And then it just does OAuth, and then you'll get into a page that looks similar to this. Now, once you've done that, right, you'll be able to go to the GitHub page for this repo, the same one that you're already on, and there should be a button for open with Gitpod, because if you have the Gitpod extension installed. If you don't, however, then you can do something else, right? So what I'd like you to do is press the fork button over here, right? And so then select your own GitHub username, and then you can keep the repository name the same as well, right? And everything else can be as is. Then press create fork. All right, and once you've done that, press refresh and you'll have a copy, an exact copy of the same repo, right? And now at this point, you can press this open button, or alternatively, what you can do is just copy this and go to Gitpod, right? So just go to gitpod.io/new and then the hash sign or the pound sign, and then paste that URL. Right, so the full URL should look something like this, gitpod.io/new, and then the full URL that you've just copied. It should be identical to mine with the exception of your username. So instead of mine over here, it'll have your own GitHub username. Now on this page, you'll have a bunch of option drop downs here, right? You'll want to select VS Code with the word browser at the end, because that means you don't have to install anything. On your computer, it just runs completely in the browser and in Gitpod. And then you press continue, and this will take about 20 seconds, I think, to spin up a cloud instance of a computer for you that is linked to this your browser. Now, if anyone is having any issues with this, right, please just jump in the chat and Ed will be able to help you out. We might open a breakout room in Zoom to be able to debug. Okay, so back to this. So I'm going to make the screen a bit bigger. Let's see. All right. Okay, so hopefully this is easier for you to see over the Zoom call. All right, so as soon as you start the Gitpod, right, it will do several things for you, right? It'll do an npm install, right? And then it'll copy the env file, right? And then it'll give you an instruction and it'll ask you to go to setup, to go to portal.hedera.com/register, right? So let's do that. And you'll also find those instructions in the README as well. So just bring your attention back to the README. So if you scroll down over here, you'll see the instructions for npm install, etc. So Gitpod has done all that for you. You just want to jump straight to step number 3, right, which is create your env file. This step has been done by Gitpod, and you'll just find that you have a .env file and you need to get your operator private key and operator ID into that .env file. So the next thing you need to do is open up Hedera developer portal. So that'll be portal.hedera.com/register. I already have an account, so it just redirected me and it brings me to this page. I'll just make that a little bit bigger so that's easy to see. So these are testnet credentials. So, you know, there's no real cryptocurrency here. It's just for us to experiment with, essentially. And yeah, so just want to give you all like maybe 10 seconds, 20 seconds to make sure you're able to get to this page. And once you're on it, we can continue. In the meantime, I'll check the chat if there are any questions, right? If you don't have an account, it's quite simple to create one. You can just create a new account. It's a kind of like signing up for any website. And then once you've verified via email or something, then you'll come here. And what it does is it creates for you 2 different accounts, right? One is an account of type ED, DSA type account. So you'll see that ED25519. And then you'll also see a second account called ECDSA. The one that we'll be using is this one, ED. It starts with ED25519. So if you only see an ECDSA account, then press that button. And then you will also get another account that's of type ED25519. And that's the one that we'll be using. All right, so I think that might have been enough time. Sound off in the chat if it wasn't. So what we'll want to do next is copy some of these values, right? So we'll want to take the account ID, right, which is this one. Just hit the copy button next to it. And then I'm going to go back into Gitpod and open up my .n file. So you'll see on the left you have a menu with all the files. I'm just going to resize that a bit. Maybe I'll bump the text size up slightly bigger, just so that it's easy to see. All right, so for operator ID, you want to paste that account ID that you just copied, and then subsequently go back to the portal, and you'll want to copy the DER encoded private key. So this one, right? And copy that. So it should start with 302 something something, but you don't want the public key, you want this one, right? The encoded private key. Go back to the N file and paste that here. Now, what I'm doing with the private keys here, I just want to quickly mention that you should never do that if this is a mainnet account, but since it's testnet, it's fine, because there's no real currency involved. Just wanted to emphasize that. Okay, so once we're done with that, right, we can do a checkpoint, right? So this is just to check that everything is working and that nothing's gone wrong. So just type this node scripts / checkpoint 01/-setup.js, right? And here it says, okay, there's been a remote mismatch because my username doesn't match this one. So that's my bad. I've been testing it directly on this repo, but yeah, if you forked it, then you should get this. And as long as there is a git remote present, I think that's fine. But if you see a message saying git not found or something like that, then please go and check it. Shouldn't be the case in the context of Gitpod. Yeah, so you should have a git check, an npm check, and a .n file check. If you get the same mismatch here, not to worry. All right, just checking the chat to see if anyone has any questions. Looks like no. Let's continue, right? So the next step is now we're going on to verify messages, right? And so if you're following along in the README, we should be on step 4, schema definition. So what we're going to do is to open up schemas, and underneath it there'll just be one file called HCS skill --v1.schema.json. For those of you who are familiar with schemas and schema validation, you know, what we're using here is something called JSON schema, which is just a means to define how a particular object or data should be structured and what are the validation rules behind it. And we'll be making use of that during within this application. For those of you who are not familiar with JSON schema, but let's say you have a background in maybe other technologies, this is kind of similar to XSLT, which is another popular form of schema, which isn't JSON based, but rather XML based, and there are many others, right? So what this does is saying that I'm going to define a schema for an object. It's going to have a type whose value must always be this. It must have an account ID, which must be a number followed by a dot, followed by another number, followed by a dot, followed by another number. So that's a regex, a regular expression. And then finally we have a username, a skill name, and a hash, which are all strings. The hash has an exact number of 64 characters, and the username and skill need 3 characters at minimum and can be a maximum of 100. So those are the objects, that's basically the structure of the object that we're going to be creating, and we're going to call that a HCS skill, right? That's the application that we're going to be building, is centered around this data object. All right, so there's nothing to do here, just some orientation for step 4. Moving on to step 5, we're going to start writing some code. So we have a schema validation. So we're going to use this schema in schema validation. So let's close that schema file and open up the util directory over here. And then the first one we'll be looking at is skill-verify, right? So just a quick overview of what this file does. I'm just going to make this a bit smaller. This skill verify function here, right? What it does is it maintains a version cache of schemas in the case that we have multiple schemas that we want. So if you want to extend this application to have multiple data types or multiple versions of each data type, then you will have multiple schemas, and you can manage that using this caching mechanism, right? And then what this does is, this bit of code does all it does is ensure that you've got the right version of the schema, the specific type of schema that you want to load for that object, and basically loads that up, right? And so once we've got the schema, we want to validate it, right? And so this is the part where you'll actually need to type something, type some code for the first time. So hopefully all of you can follow along. So if you take a look at the README, I'll just sort of emphasize this point. We'll scroll down to step number 5. This is where we are at the moment, right? And we're inside util/skill-verify.js, and we'll want to find this comment over here, note schema validation, which will be inside the function with this name, right? And then we want to do this, right? Const inst valid is equal to validator, and then pass in an object, right? And that's exactly what we're going to do over here, right? I'm going to copy paste that, right? So I'm just showing you that how to use the README and follow along with the tutorial. I won't be doing that in the subsequent steps, right? So for schema validation, we've selected the validator, we've loaded it up from the cache, right? Which in turn is read from the schema file that we saw earlier on. And then we're going to simply call that validator as a function and pass in the object. The object is basically the one that was passed into the skill verify function, which we will be using later. All right, next step is step number 6 for custom validation. So find the comment that looks like this, and then underneath it you'll find a couple of bits of code that need to be changed, right? So firstly, we want to update the object to include a hash, right? So we're not going to trust the hash that's already present. We're going to replace it with an existing one if it exists, or if it doesn't exist, we're going to add a new hash. So that's what the add hash function does, right? And then I'll pass in the object. Now, if you're curious as to what the add hash function actually is, you can just hover over it and hold down the command or the control key, depending on your operating system, and click on it. And then you'll go to this file called objects.js, which contains the definition of add hash, right? And you can see we're using some built-in functions from the Node.js crypto library, and we're also using a serialize function, which is kind of similar to json.stringify, if you're familiar with that, but we're actually using a third-party library so that we get a stable key order so that hashing is consistent, right? And feel free to explore that in more detail in your own time. So now we've got an object and we've added a hash to it, and then we're going to do a comparison, right? We're going to say if the original object hash matches the new object that we just recomputed the hash for, right? Dot hash, right? And so now we have our new if condition, right? And so if there is a mismatch, then we're going to return this validation error, right? Much in the same way that the validator, that the JSON schema validator returns validator errors, we're going to simply return one in a very similar format, right? And if nothing has gone wrong, then with either of those validations, right? So we've got the schema validation and also this custom validation. If both of them are successful, then we return undefined, and that means validation is passed essentially, right? So now we've made a couple of changes. I'm going to expand the terminal once more, right? And I'm going to run the node scripts /checkpoint02/-validation.js. And what this does, right, is essentially checks if this skill verify function that we just completed the implementation of, whether that is been successful, right? So let's explain the output. Just make that bigger so that we can see more of it. So we're expecting 3 validation failures and 1 validation success. So we're giving it essentially 3 objects which are invalid, followed by a single valid object. And we can see from the output that we've got exactly what's expected. I think what might be more interesting is to take a look at that that file that we just ran, right? So the checkpoint O2 validation. So this will give you an idea of what the objects are, right? So this first object whose validation failed, it was because the type is not of type HCS skill, right? The second object does have a type of HCS skill correctly, but the skill name should be a minimum of 3 characters, and it doesn't meet that requirement. And then finally, we provide an object that passes the schema validation, right? But our custom validation with the hash doesn't work, right? The computed hash actually should be something else. And finally, we've got an object which is basically the same thing as this previous one, but with a correct or matching hash, and then that one passes the validation, right? So if you think about it, these checkpoints, they're kind of similar to unit tests or integration tests. So that's essentially what it is, right? But we're just using them as checkpoints to validate that, you know, we're following along with the tutorial correctly. Now, if you get unexpected outputs, that's fine. We can continue, or you can copy what you see on the screen right now. And for those of you who are unable to sort of follow along or are getting a checkpoint error failures, right? So you should get 3 validation errors, like you see here, followed by 1 validation success. So if you don't see that, just send a message in the group chat, and we will form a breakout room, and Ed will help you to get back onto track. All right, so that's verification. Now let's move on to the next step, which is to publish messages. Now I'm just going to jump back to the README over here so that you can see here. So now we're in this section, publish messages, right? So we're going to be doing step 7, 8, and 9 in this next section. So going back to Gitpod, right? We are going to open up util /skillpublish.js, and inside of it, we want to find the skill publish function, which is right up top, right? And here are the steps that we need to implement, step 7, 8, and 9, right? So for the first one, right, we are going to create an object, this one, by invoking add hash on the skill data object, right? So this is fairly simple in the sense that we've already done this before, right? We did that within the previous file, skill verify, so it's pretty much the same thing, right? We've got a skill data object. This time it doesn't have an existing hash on it, and we're not using it to check that the hash matches, right? Instead, what we're doing is we've got an object that has no hash, and we're just adding a hash for the first time. Subsequently, we're going to do step 8, where we verify the message, right? So this is where we call skill verify, which we just implemented earlier on, right? Skill verify. Now, and we call that function that we implemented in the previous steps, right, on this object that we've just constructed, right? So skill verify is over here. This is the function that we just implemented previously, where we call the validator followed by add hash, right? So some of you might be wondering, oh, why am I doing add hash here and then also doing add hash in skill verify? It's for 2 different purposes, and also because we want to ensure that the data that is coming into this into skill publish, right, by the parameters here, we don't know whether that's valid, right? So that's why we need to do skill verify over here before we even get to publishing it. So we do this as a sort of a pre-flight check, skill verification before doing the actual publishing, which is the objective or the main function of the skill publish function that we're in right now. Right, moving on to step number 9, we have submit message to HCS topic, right, over here. So what we'll want to do is, let me just make this a bit bigger. So we've got topic message, message submit transaction, and we're constructing a transaction before we execute it. And what we need to do over here is to create some input parameters for this particular transaction. Now, I'll highlight, since this is the first time that we're doing it, that topic message submit transaction actually comes from this library over here, hashgraphs/SDK, right? And just so you know where that comes from, it came from an npm install, right? This library over here. So this library, hashgraph/SDK, is the JavaScript/TypeScript version of the SDK, and there are multiple other versions, right, of this SDK. There are also, if I'm not mistaken, there's Java, there's Golang, there's Swift, in addition to JavaScript and TypeScript. And then there are a few other community-supported ones, so unofficial SDKs as well. Okay, and what the SDK does is allow a client application to interact with the Hedera network by constructing the transactions appropriately and formatting in a direct way. So some of you may have experience with EVM style of development. So this SDK is sort of analogous to the something similar to Web3.js or Ether.js or VM, right? So if you're familiar with those, this is basically the Hedera version of it, right? So those versions, those ones only allow you to interact with EVM compatible networks, and you can indeed use them to interact with Hedera. But if you want the full set of Hedera services, for example, Hedera Consensus Service, then you will need the Hedera's official SDK, right? So we're using topic message submit transaction, and I'm going to jump back down to this one, right? So we're back in the steps now. We're back on step 9. So what we'll want to do here is set a topic ID, right? And pass in the topic ID that was passed into this function over here. So it's the function parameters, and we've already got the object that we want to pass in as the message, right? So message is HCS message, and just by way of clarification, HCS message is actually the serialized version of this object that we just validated. Then once we've done that, right, we execute. So that actually submits a message to the Hedera network. This client, by the way, is essentially an account on Hedera, right? So it's got an operator ID and a private key, and that is used to construct the client. And that client is essentially signing that transaction before executing it, submitting it to the network. And then once the message has been processed, we'll get a receipt, right? And the receipt will tell us several things, including the status, whether it was successful or not. It'll give us the sequence number, which is when you do a publish subscribe, we've got fair transaction ordering, so we know exactly what order in which these messages were submitted or accepted onto this queue of messages, right? Or this queue of HCS skills, I should say. All right, and then we have some other data inside of it as well. So we save that file, and we are done, right, with the skill publish thing. So now we're ready to run the next checkpoint, right? So we're going to do node scripts/checkpoint03 -publish.js, right? And we can see over here that we got one expected validation error, followed by another one where we expect a success and a hash. So let's take a look at that code, right, that we just ran, the script over here, right? So the first one, we try to publish an invalid skill. So as we know over here, If the skill name is less than 3 characters, that doesn't pass validation. So that's exactly what the validation error was over here, right? You can see that over here. And then with the second object, right, it's a valid object, so we get back a completed status as well as a hash. So that's what we've done. All right, so now for those of you who didn't get a result that looks similar to this, right? If your result from running the checkpoint doesn't look similar to this, please sound out in the chat, and Ed will be able to sort you out in a breakout room. All right, let's continue. So the next step is to read messages, right? So this is where we essentially say, hey, we've submitted messages to the HCS topic. Let's get some messages back, right? So to do that, I'm just going to highlight where we are. Before we do that, I'm going to highlight where we are inside of the workshop steps. So check out the read messages section. Inside of this, we're going to be doing step 10 and step 11, right? And it's going to be within util skill-subscribe.js. All right, so let's open up that file, skill-subscribe. Get a bit more space. All right, so the first thing we're going to do is to extract all of the historical HCS historical messages from this topic, right? And that's what this skill get all function does, right? So this is for step 10, right? So I'll just show you a Swagger UI over here, right? This page over here, testnet.miranode.hedera.com. I'll just pop that into the chat. You can find it inside of the README anyway. It's basically an interactive playground to interact with the Hedera mirror nodes. The one that you want to go to that's relevant for this one is you scroll down to the section for topics, and then underneath it you'll see topic/topic ID/messages. That's the one that we'll be invoking, right? So you can play around with this interactively. You can press the try it out button, and then you can fill in whatever values you want inside here, and then press execute, and you'll get a sample result. We won't be doing that today within this interactive page, but instead we'll be doing that right here in this code, right? So this is actually the same as this path over here. It's exactly the same, right? But we just need to substitute in the value of the topic ID. So let's just do that. Topic ID dot toString. Right. So topic ID might be a string, in which case .toString is irrelevant. But if topic ID is a topic ID object, then the .toString version formats it appropriately before putting it inside here. All right. So that's your mirror node URL. Right. The next thing we need to do is we need to await fetch and mirror node URL. Right. So that's pretty straightforward. We created a URL, and then we basically issue a HTTP GET request to that URL, and then attempt to parse the response. Right. So in this case, we know that the mirror node returns messages in the format of base64, right? So we just need to decode that in parse skill. You don't need to do anything here. It's already been implemented for you. So it says, okay, I'm going to decode it using Node.js buffer, right? Buffer.from, and then base64 format and whatever the input message was. And then once it's done that, it will do a skill verify. And so if the message that you've received has been verified correctly, then it will display in the UI. If not, it'll be known that there are validation errors, right? So that's the idea behind this. Moving on to the next step, right, which is for step 11. We're going to do topic message query, right? So this is essentially saying, hey, I want to do a a persistent subscription, right? So this one, right, the previous one in step 10, right, we have fetch, which just gets it one-off, right? You make one request, you get a bunch of messages, and then you do what you need with them, and then that's it, right? So it's a single transaction and happens once. Whereas with topic info query, with topic message query, it does a subscription. So it's saying, hey, I don't want the historical messages, which is what the mirror node query was used for. I'm going to subscribe and listen to future messages that are on this particular topic, right? So that's the main difference. Topic message query again is from the Hedera SDK that we've imported. So set topic ID, and then we want to pass in topic ID, and that's all there is to it, right? So we've got a subscription and we return it, and whenever a single message is returned, then that gets sent to the parse skill as a callback, and then it does the same thing as what we did in the mirror node earlier on, where we deserialize it and basically interpret it, and then once we've got an object, then we verify it and then treat that verified or unverified object accordingly. All right, and that should do it. So now we're able to do the checkpoint, right? So let's run node scripts /checkpoint04-subscribe.js. Run that, and let's see its output. So we'll see skill get all with some message counts, right? And then it'll wait for a while, and then it'll have skill subscribe message counts, right? So skill get all basically queries the existing HCS topic and says, okay, so I have 23 valid messages in there and 2 invalid messages in there. Then actually let's just show what it does. Code, open up that same file. So here's what it's doing, right? So it calls skill get all, and then it counts the number of valid and invalid and outputs that, and that's where we see this line over here, right? Then what it does next is to do skill subscribe, and also counts valid and invalid, and after it's done the subscription or started the subscription, then it does a skill publish where it publishes one new skill that does happen to be valid. Then it waits, and then it outputs the valid and invalid counts, right? That's essentially what it does. Okay, so that's the checkpoint. Now, if you get an output for checkpoint 4 that looks similar to this, all good. If you don't, then please stand out in the group chat, and we'll sort you out in a breakout room. Excellent. All right, let's continue. Right. So now we're at the final stretch with only one step left. Just by way of orientation, I'm going to go back to the README file in the GitHub repo. So client application, we've just got one step left, which is to subscribe to the topic, right? So this will be the front end or the browser application that will tie everything together. And once we've done that, we'll actually have a bit of a hands-on session that doesn't involve any coding whatsoever. All of you who are participating can just simply join in. You can simply join in and interact with the application once this is completed. All right, so let's take a look at this, right? Going back to Gitpod, let's open up close util and scripts now, and we'll go to front, and we'll open up index.js. All right, so within this, right, we're looking for a function called sub-existing topic, right, which is this one over here. And then we'll need to find the node that says subscribe to topic, which matches the name of the step, right? And what we really want to do here is we want to fetch the AP. We want to call fetch, which is essentially invoking a HTTP request, right, on the API within the server that we've implemented that triggers a subscription for that particular topic. So let's do that over here. So let's see. I'll just show you in the back end the server that I just mentioned, right? So here's a server, right? And it has implemented multiple APIs, right? So the topic get, topic create, topic subscribe, and topic message create, right? And the one that we'll be modifying is this one over here. Oh, sorry, the one that we'll be calling is this one over here. So API/v1/topic/subscribe followed by a topic ID, which is I guess a URL parameter. All right, so let's go back to the front end code, and we'll just put in that API over there, API path over there. And notice that I've used backticks instead of single quotes, and the reason for that is because I want to do string interpolation to substitute in the value of topic ID, which has been read in from a text field in the user interface, right? And that's all there is to it. So once we invoke this fetch, that will trigger a subscription on the backend if it hasn't already been subscribed, and henceforth the messages that have been submitted to the topic when the HCS obtains that, or I should say publishes that event, and if you're subscribed to it, sorry, wrong word, publishes that message and you're subscribed to it, then the backend server will essentially relay that over WebSockets to the front end, which will receive it, right? And that's it. So this one doesn't have a checkpoint, right? However, we can do this interactively. So the code to run here is npm run server, right? So npm run server, that's it. I'll copy that, and that will automatically open up the website that has that we just created. So npm run server, I'm going to paste that inside the chat just for your convenience. Right, so you can see that this is listening on port 3113, and as soon as that happens, Gitpod has been configured such that it will open up a new tab in your browser for whatever that is. Now, what I'm going to do over here, and you don't need to do this, right, is to press subscribe to topic, to new topic, I should say, and I'm also going to right click and inspect, and then press console, so that I can see what's happening over there, right? So after a few seconds, you should see that topic ID followed by a newly assigned topic ID. I'm going to copy that, and I'm going to go to hashscan, right? So that's hashscan.io, and paste in a topic ID that I've just copied, and press paste, and you can see here that it hasn't appeared yet, right? So the reason why I did it like this is so that you can see that there is a difference between the Hedera nodes and the Hedera mirror nodes, right? So the Hedera nodes that actually process the transactions, they do so immediately, whereas the mirror nodes, which is what hashscan uses, it takes a few seconds to propagate. So let's search for that again. Did I copy that wrongly? Interesting. This is indeed testnet. Let me check what's going on. Okay, the topic message query has already succeeded. All right. Oh, and before I continue, I'll just copy this Gitpod URL. And for those of you who are running your own version, you can continue doing it in your browser within your own Gitpod page. If not, I'm going to paste this over here and then press the, and then for those of you who want to follow along, you can just access it on this Gitpod URL that I've just pasted into the chat, right? Which is 3113-BGUIZ, blah, 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 that one, right? So, yeah. I am not completely happy that that hasn't appeared just yet, so I'm going to try it one more time. I'm going to go dashboard, topics. Oh, there we go. It is indeed there. Huh. Interesting. Okay, so it just took a little bit longer than usual. Usually it takes only about 5 seconds to propagate from the Hedera nodes being able to see it to the mirror nodes being able to see it, but we got there. A few extra seconds. Okay, that's cool. So once we're done, right? Sorry, wrong tab. Right. I would like all of you who are following along, right, to this topic ID, right, to who are following along to copy this topic ID that I've just pasted into the chat. So it's 390.0.3974.007, right? So copy that and paste that inside of this text box over here, and then press subscribe to existing topic. Right, and then you should see this output over here. You should see subscribing to socket ID, HCS skill dash, and then followed by the the topic ID. Right, once you see that, you know that you're listening to this, right? And then now let's enter some skills, right? So I'm going to enter HCS demo workshop, right? That's what we've just done. I'm going to enter a nickname. Oh, it looks like Ed is also following along. So Ed is learning blockchain, and that's his account ID. And I'm going to copy my account ID from the Hedera portal. I'm going to copy this and paste that there. Press submit. Right? And then you'll notice that after about maybe a second, it appears at the bottom. So for those of you who are subscribed to that topic, you know, in your UI, you should see the exact same thing as us, as you see on the screen right now. And I'd encourage you to enter a skill that you've learned today. You know, it could be this HCS demo workshop, or it could be anything else. Maybe one of the topics covered in the presentation. So if you can fill in these 3 text fields and then press submit, just make sure that this one needs to be at least 3 characters, same with this, and this one needs to be an account ID. So that's a number followed by a dot, followed by a number, followed by another dot. So it has to follow that format. And while we're waiting for some of you to chime in, right, we can yeah. So while we're waiting for you to do that, I'm gonna do oh yeah, I was going to go back to hashcan. So this is the same topic as before. You can see it's empty, right? But here we've got 2 messages on it. Now if I do a refresh, right, we can actually see the raw version of it. So in this application, right, we have a user interface that has parsed the information and displayed it in a certain way, right? But inside this, you just got the raw data, right? So you can see the exact JSON object that we see over here, right? And we can, if you click on each of them, you can actually see, okay, this was the HCS submit message transaction, and these are the details. We can even see more things like sequence number, etc. Right? So let's see if anyone else has entered anything. Aha, okay, there we go. We've got a test user inputting some stuff. All right, so I encourage you to follow along, and this essentially demonstrates a publish subscribe queue or PubSub methodology. So the topic is essentially the queue, and these messages are both published by you when you press the submit button, and also subscribed to by you, which is demonstrated by when these lines appear within the topic. Okay, I see some messages in the chat. Let's see what's going on there.
What changes when using the submit key? Brendan, do you want to take that one?
Oh, okay. So I believe submit key is to do with making a topic not able to be published to by any account. Is that right, Ed?
Yes, that is the right line of thought. So if a topic has a submit key, that means that only the people with that cryptographic key will be able to submit messages to that topic. If a topic doesn't have a submit key, it means that topic is public, so anyone can publish to that particular topic.
So,
and by the way, whether there's a submit key or not, anyone can subscribe to a given topic.
Yes. So that reminds me actually of a question from someone else earlier on, and I said, okay, I'll cover this later on. So thanks for the reminder, right? So the question was, in general in Hedera, like if it's a public blockchain, meaning anyone can read the data on it, is that actually like what if we have a privacy a use case that requires some data privacy on chain, right? And this demo specifically doesn't demonstrate that. What it really does demonstrate is validation. So if someone submits invalid data, it discards it, at least as far as the application is concerned. And so even though the data there is a message in the topic, right, the UI won't display that, right? And we verified that using the various checkpoints along the way, although you can't really see that in action because it doesn't allow you to submit in the UI as well. But let's say, and coming back to the question about privacy, right? So in the case of HCS, if you set a submit key, which has got a threshold key, meaning, for example, a multi-sig. So you can say, I allow any one of these 10 keys, so 1 of 10, so these 10 particular users with these 10 particular accounts and their associated keys, they are able to submit to this topic. So then only those 10 users are able to submit messages to the topic, and it's not a free-for-all for everyone. Right, so that's the point of the submit key. So that's one sort of privacy mechanism. But then the second one is not solvable through Hedera technology itself, but it's more of a BYO thing. You'll notice that the raw data that is inside of here, right, is basically in plain text, right? So anyone can read this data. However, if you were to encrypt that data client side, and then basically what you see here is just basically random looking characters, right? And so anyone can read those random characters, that's fine. But then the client on the other side, your intended recipients, whom you want to share this data with, right? They will be provided by you through some other mechanisms, a key to be able to decrypt that data and read it. So you can store encrypted data on a public blockchain. It's just that the mechanism to do so isn't provided by the network, the DLT itself. You just have to BYO that part of the mechanism. Yeah, cool. Let's see, what else did I want to cover? I think that was the end of it. And I think I won't have time to go through this section over here where it details how the front end and the back end are connected together and how it all ties in. But I encourage you to read that up, read along that on your own. Now, one final thing is that Gitpod, is running a cloud server, so that's running in the background. I would encourage you to go to gitpod.io/workspaces once you're done. You don't need to do that now if you want to continue playing along. And you can press the stop in this vertical ellipses button over here, and then once it's stopped, you can press delete as well if you want to, or you can, I believe you can actually reopen it again if you want to, right? So I'm done with this, so I'm going to delete it. And for those of you on a paid plan, that's a billable hour. For those of you who are on a free plan, that's not really you don't get billed for it, but you do use up your free quota. So it makes sense to stop it as soon as you're done. All right, just housekeeping note. So congratulations, you have now built a working application on Hedera Consensus Service. If you got this far, well done. If not, please let us know and we will be able to follow up with you after the session. Now, this comes back to the question as well from earlier on about possible stretch goals, right? So I've listed a few of them here, right? So for example, this is an example where you can use a slightly more complex schema to describe skills. So this, by the way, is a real schema that's in use by the Singapore government, where people do upload their educational certificates, and that's part of the inspiration for this particular application, this demo application. And by the way, talking about real world use cases, right? If you apply for a job in Singapore, right, chances are you'll be asked to submit to not turn up with your actual physical university certificate, for example, right? You'll be asked to upload it on OpenCerts, right? And then they'll just, sort of verify it over there. So that's kind of a cool use case to see where, this kind of application can go further. And then coming back to the specific question, right? So there's set submit key on create topics transaction. And then I also mentioned threshold key, which is where you can have multiple people or multiple accounts, I should say, essentially operating a private HCS topic, right? Then there's another one which I wanted to highlight, which is you'll notice that this application, you can enter any account ID that you want to do, but it doesn't actually verify that. So you can actually do that, right? If you modify the skill verify function. I just didn't want to do that or make the application too complex. And moving on to very hard, right? So right at the beginning, I showed you that there was a schema folder with just one schema file inside of it, right? That schema file, is just one. You can have multiple different types of schemas for multiple types of entities. So for example, in this application, you could have a user data type as well as a skill data type, and then you could have like some sort of connection, like one user can have multiple skills, for example, right? So then based on that, you can start to see that's kind of like the seed of like, hey, how do I create an entire application where I'm using HCS as the source of truth about my data, right? So you can talk about SSID, credentials, etc., etc. You can actually build on this application and take it much further. All right, that's it. And yeah, so just a quick recap. So we've created an application that is built on top of HCS. We've used the Hedera SDK, right? We used it to create a topic. We used it to send new or create new messages on that topic. And we also used it to subscribe to messages on that topic, which essentially translates to queue, publish, and subscribe. Then we've also used the Hedera Mirror Node APIs to retrieve historical messages. So with subscribe is only future messages, so you can get historical messages as well. And then we also did a bit of learned a few concepts that were outside of the scope of Hedera specifically, but relevant in this case. In this case, it was using hashing as well as JSON schema for validation. And that's it.